I'm Anil Kumar, and in this video we will understand combination of quadratic and linear function. Now let me take parent functions to discuss combination. Let us say f of x is equals to x, so that becomes a linear function, and let us say g of x is equal to x squared, so that becomes the quadratic function. Now as we know, there are no restrictions in the domain of these functions, so x belongs to real numbers for both these functions, right? So their domain has no restriction. Since their domain has no restriction, they can be combined in in without any restriction, right? So in the domain of real numbers. So when we say combination, let me remind you what I mean. So combination means we can add them, subtract them, multiply them, or divide them. So that is what we're trying to do with these two functions, right? Now, if I add them, then what happens? Add or subtract them. If I do that kind of a combination, then what really happens? So let us discuss that part first. So what we will do is, let me write like g of x plus f of x. Now, combination of addition is commutative. If you write g of x plus f of x, it is same as f of x plus g of x. That is very clear, right? Now, we also know one thing before we get into this graph, that is even and odd function. We know that linear functions are odd functions, right? So these are odd functions. However, x squared is even function, right? So even function. Now, if I combine these functions, then will it be even or odd? That is the first test which we should do, right? So let us check. So let us say we combine them and we form the function h of x, right? So now we will check what h of x is. So basically it could be written as x squared plus x. Now if I'm trying to check for even or odd, let me just complete this as even, okay. Now then what do we say? How can we find whether it's even or odd? We have to really check for h of minus x. So let me do it in a different thing and try it here. So h of minus x will be equals to minus x whole square plus minus x, and that gives us x square minus x, right? So clearly it is not minus of hx nor it is h of x, and therefore it is neither, right? So first thing which we get about even and odd is that h of x is neither. So it is neither even nor odd, okay? So it is neither, okay. So that is what you know. Now, next let us combine them and see how the function will look like. So we'll consider h of x now, which we have already written as x squared plus x. Now clearly what we see here is that I can factor x and I get x plus 1. That means it is still a parabola, but this parabola now has two roots as shown here. So this is the function which I have drawn. It is h of x, where we are combining the linear function and the quadratic parent functions, right? Here, as you can see from the graph itself, which I have drawn from this equation, we have two zeros. One zero is at minus 1, the other one is at 0. So what really happened by combining a straight line and the parabola is that the parabola shifted left and down, resulting into two x intercepts, right? And it kind of gets translated, and so that is what you really get here, right? So but still remains the parabola, so that is kind of important. So combining them maintains the shape and the characteristics of the parabola. However, we may have more or less number of zeros depending on how we combine quadratic and a linear function. So what you gather from here is that the combination of linear and quadratic function results into a quadratic function, right? always, correct? So it is always a quadratic function. So when you add or subtract, you get a quadratic function. Now what happens when you multiply or divide? Now let's look into that part. So if I have another function, let us say m of x, where we multiply f of x and g of x, right? Then what happens? Then we get x times x squared, and it becomes cubic equation, correct? Now when we multiply this function, then it becomes a cubic function, and we know cubic function is odd, right? So when you multiply even and odd function, you get odd function, correct? So you could also prove it like we proved that neither m of x will be equals to, as we wrote, x cube. Let me find what m of minus x is. So it will be equals to minus of x cube, which is minus x cube, right? So we get minus of m of x, and therefore we can prove that it is odd function. Is that okay? So when you multiply this function, it becomes an odd function, correct? Now if you divide function, then what happens? Let me call that function as d of x, right? So divide, we could do either f of x over g of x or g of x over f of x, right? Now in both the cases, what you will find that there will be restrictions, right? Since the denominator cannot be 0, so f of x is not equal to 0. So when you divide your functions, there could be additional restrictions. As you can appreciate here, denominator cannot be 0, and denominator is 0 for x equals to 0. So we have here that x belongs to real numbers. However, x should not be equal to 0, right? Since x equals to 0 gives f of x as 0, right? Now this particular function, when you divide g of x by f of x, gives you, let me write their values now. There's little space, so I'm just using every bit of it, kind of like this, which is x, where x is not equal to 0, right? So you get a straight line where this is not equal to 0, and when you test it out, since it is x, we know it is odd, right? So if you multiply or divide even and odd functions, you get odd functions. That is what we collect from here, correct? But if you add or subtract even and odd function, you get neither. Now this is a very general rule which could be applied to all the functions if we are considering even and odd, right? Now division, as I said, is not commutative, right? Multiplication is commutative. Whether you multiply x squared by x or x by x squared, you get the same result. But when you divide, you don't. So if I do the reverse, for example, if I do, let me call this as p of x, okay, or r of x as a rational function, more, better. Okay, so if I do f of x divided by g of x, what do I get? I get x over x squared, which is 1 over x. Yes, the restriction is same in this case also. X belongs to real numbers where x is not equal to 0, but it is 1 over x, kind of different function, reciprocal function. Here also you will notice that 1 over x is indeed odd function, right? So it makes sense. So when you multiply or divide two things with different signs or opposite signs, you get opposite sign, and that is the reason why these are odd functions. But I hope from this video you can understand a couple of things. One is that when you add or subtract even and odd functions, you get neither. But when you multiply or divide these functions, you always get odd functions. That is one thing. Second thing which you understand here is that when you have a combination of addition and subtraction of linear and quadratic function, you always get a quadratic function. But when you divide or multiply, you may get a reciprocal function or a linear function, right? With that, I think you have fairly good knowledge, and we'll take a few more examples of combination of functions and then move on in further details. I'm Anil Kumar. Subscribe to my videos and learn a lot. Thank you and all the best.